Hello. Today I'm going to be talking to you about physics, more specifically how to find the mass number and the charge of a nucleus after it has undergone several types of decay. We're going to start off with showing you what a alpha decay looks like. To do this, we're going to use an apple because an apple is very important to the world of physics, because obviously Sir Isaac Newton got hit in the head with an apple and he supposedly just knew physics after that. I think that's how it goes. But so it's gonna, the apple, I split the apple into two halves. This half is going to be representing the neutrons of the nucleus, and this half will be representing the protons of the nucleus. An alpha decay is when an unstable nucleus gets rid of two of its neutrons and two of its protons. So the atomic number is going to be decreased by 2, because that's the number of protons, so that's going to be 2 less, and then the atomic mass is going to decrease by 4, because the atomic mass is protons plus neutrons. So we're going to be losing 2 neutrons and 2 protons, so 4 total from the atomic mass. So I made this apple. I gave it 6 protons and 6 neutrons. So this is now representing a carbon atom. And we're going to make this carbon 12 atom have a alpha decay. So what's going to happen is there's 1 proton, and then there's another proton. So now it's only got 4 protons. It's a neutron. And there's a neutron. So now it's only got 4 neutrons. So the new mass number, if you want to count, is 4 protons plus 4 neutrons is 8. And then the number of protons is 4. So now this apple went from representing a carbon-12 atom, then it went through an alpha decay process, and now it is representing a beryllium-4 atom, or a beryllium-8 atom, excuse me. So now that we have a beryllium atom, we're going to make this have a beta-minus decay, which is where a neutron becomes a proton. And then also what happens in that kind of decay is an electron is emitted, so the overall charge becomes positive. So what I did here for this beta-minus decay is I took out one of the neutrons and replaced it over here as a proton. Now let's talk about gamma decay, which is the easiest to calculate type of decay. It's when a neutron or a proton is in an excited state and it just simply goes to a lower energy level and it emits a photon. So the easiest way to represent that with an apple, because this kind of decay does not decrease the amount of protons or neutrons or the overall mass at all. It's really just kind of like the stem, the useless little stem that doesn't really affect how much apple you can eat. That just kind of comes off, and there's your gamma decay.